Hi, Wayne here from Sears Parts Direct. Today we're going to talk about troubleshooting a riding lawnmower engine that clicks when you turn the key but won't turn over. A bad starter solenoid often causes this problem, but not always. The mower could have a bad starter motor, a wiring failure, a weak battery, or a locked up engine. We'll show you how to find out what's wrong. First, we'll check for a weak battery. The click you hear when you turn the key means that the starter solenoid coil is getting power. The starter solenoid only needs a little current to make the solenoid coil click. But the starter motor needs a lot of current to spin the motor. So a weak battery could have enough current to trip the solenoid coil, but not enough current to crank the engine. To check the battery, use a multimeter to measure DC voltage across the battery terminals. Turn off the ignition. Access the battery. In this type of riding lawnmower, you lift the seat to get to the battery. With the multimeter set to measure DC voltage, touch the red multimeter probe to the positive or red battery terminal and the black meter probe to the negative or black battery terminal. A fully charged battery measures more than 12 volts DC. To provide enough current to spin the starter motor, the battery typically needs to be at least 75% charged. Here's a chart that shows you how much charge the battery has based on voltage. Charge the battery if it's weak or dead. The starter motor should spin the engine after you recharge the battery. If not, the next step is to check the cables. If the battery is okay, then corroded or broken wire cables could prevent the starter motor from getting power. If you find corrosion on the battery terminals and cable ends, here's how to safely remove it. Put on work gloves and safety goggles. Disconnect the negative cable and then the positive cable from the battery. Use a wire brush to clean the cable ends and battery terminals. If brushing doesn't remove it all, sprinkle baking soda over the terminals and cable ends and then moisten the baking soda. The baking soda and water will bubble vigorously and dissolve the corrosion. When the bubbling stops, use a toothbrush to remove any remaining corrosion. Wipe off the terminals and cable ends with a shop rag. Thinly coat the battery terminals with petroleum jelly to help prevent corrosion. If you found no corrosion or the motor still won't start after you remove the corrosion, check if the red battery cable is delivering power to the solenoid post by measuring voltage on the red terminal post. With the multimeter set to measure DC voltage, touch the red meter probe to the red post on the starter solenoid and the black meter probe to the negative terminal on the battery. It should measure more than 12 volts. If it doesn't, replace the red battery cable. A word of warning here. Don't let the meter lead touch both the solenoid posts at the same time, or you'll see a severe spark. If the motor still doesn't turn over with a good red cable, the solenoid is next on the list of likely suspects. Next, we'll check the starter solenoid by measuring voltage on the black post at the same time the solenoid clicks. You'll need some clip-on meter probes to hold the probes on the wires as you turn the ignition key, unless you have a helper to turn the key while you hold the probes on the wires. Disconnect the black starter cable from the solenoid post and attach the red meter probe to the post. Clip the black meter probe to the negative battery terminal. Hold the ignition key in the start position. You should hear the solenoid coil click. When the solenoid coil clicks, the multimeter should measure more than 12 volts if the black post gets power. If it measured no voltage when the solenoid coil clicked, replace the starter solenoid. If the multimeter measured more than 12 volts on the black solenoid post after the solenoid clicked, you know that the starter solenoid works. Now we'll check the starter cable that connects the solenoid to the starter. We'll use a voltage drop test to measure resistance through the starter cable. Using a voltage drop test is more accurate than a simple resistance test for a large cable with many copper strands. A simple resistance check detects any current. It can't detect whether the cable can carry enough current to spin the starter motor. We measure voltage, also called voltage drop, from the solenoid post to the starter motor stud. Ideally, we should measure less than 1 volt during this test, indicating voltage is nearly the same at the solenoid post and the starter motor stud. If it's more than 1 volt, it means wire strands inside the cable are broken. To start the test, reconnect the black starter cable to the solenoid post and clip the red meter probe to the cable lead. Lift the mower hood, disconnect the spark plug wire so the engine has no chance of starting. Remove the right dash panel for a better view. Clip the black meter lead to the cable lead that connects the black cable to the starter. Hold the ignition key in the start position and check the voltage reading after the click. If you measure a drop of more than 1 volt through the starter cable, replace the starter cable. If the starter cable is okay, you know the starter motor is getting power. Since the motor isn't turning, we've narrowed the failure down to a seized engine or a failed starter motor. We'll check for a seized engine, and if it's not locked up, we'll know that the starter motor failed. To see if the engine spins, remove the plug from the screen above the flywheel to access the flywheel bolt. Use a socket wrench to rotate the flywheel bolt clockwise and try to spin the engine. If the engine won't spin because it's locked up, have a service technician diagnose and repair the problem. If you can spin the engine, replace the starter motor because it's not spinning the engine when activated. If you follow these steps, you should be able to get that lawnmower engine started so you can get back to mowing.